And again, if you're taking Algebra 2 next year, or even if you're not, all of these skills are going to be used sometimes again in math. So whether or not it's when you're taking the ACT, or you're taking like even a college placement test, it's going to be stuff we want to know how to do. So it does not hurt for all of us to go back over it. So the whole front side is asking us just to simplify. So when it says to simplify, that means we can't actually find an answer. We're just going to get it as like kind of crunched down and like single like values as we can. So trying to make it as simple as possible. So these first few here are really just talking about like distributive property. So I'm going to give you guys a chance to look at like these 6 questions and see if there's any you guys think you know how to do, or have no idea.
I think I know how to do the first one.
Okay, we'll talk in a second. I'll give you guys a few minutes to look at it. I'm not going to leave you too long, but. Not solved. So like just like kind of get them like more condensed. So like for instance, like look up if I said 5x plus 4x, 9x would be simplified.
Ah, okay.
That's all.
Okay, we'll follow. Ooh. Oh.
Just like this.
You can work on your you're not disciplined on your tests. So if you want to work on your note card or work on anything like that, every review, you're welcome to do that. Okay. Yeah. Yeah. Foil.
I wasn't in that section, but I knew you were that's fine.
Yeah. Organized binder. Oh, sorry. I'll go. Yeah. Yeah. Okay. Do we need a few more minutes? A few more? And you guys, it's totally okay if you don't remember it. I mean, most of you guys, I probably was your teacher for it. I'm not offended. I know we forget things. Like, just like I've taken classes that I don't remember what I learned in chemistry. Obviously, it's been, 25 years since I took chemistry, but there's just things you're not going to remember. So, obviously, this was a lot less than 25 years ago for you guys. So, unless you're secretly old. I know. So, okay, guys, we'll talk about some of these. So, in number 1, Frog Bunny knew what he's doing. So, what do you want to do there? What'd you do? Yeah. So what he said was he took the -1, and some of you guys might be like, "There's not a -1 there." He thought of that as -1 here, kind of like the M stands for mode. We're keeping track of how often the guy comes around and mows the grass. Because we were being sassy yesterday, right, Miss Miller? She asked what the M stood for yesterday. That's us writing down that he mowed the grass.
In the same spot.
I wrote that to keep track of how often he mows the grass.
Oh! You know how he goes around the same spot every time?
We think he gets paid by the hour, and so he just shows up all the time and just
He goes over the grown grass, like 6 inches.
And it was wet yesterday, and I was like, sorry if that's somebody's grandpa or something. He is somebody's grandpa, I'm sure.
However, the kids over in daycare are very excited about this cart man. Or the tractor man. The little kids were out there during the fire drill. Tractor man!
Well, yeah, I mean, if it's getting come by the hour.
Okay, guys, so let's focus here. So we're distributing this -1 in, and it changes the signs of both of these. And then what you have to do is look and see what's alike, and we call those like terms. So this -2n and the positive 10n go together, so they're like terms. And so I was explaining this to Luke over here he just was asking about the word simplify. And it just means kind of putting things together that go together. So -2, +10 would be 8n, positive 8n. And then that -9 doesn't have anything to go with, so we just leave it. And I know it seems weird to leave it this way because typically in geometry we solve it, but being able to simplify these problems was kind of the first steps of algebra. So being comfortable with simplifying is what we're kind of going back over.
Oh, it's because you're subtracting. Oh.
Why is it 9? -9?
No.
Oh. Are you okay?
I had plus 15.
Oh, yeah, it's a -2. Okay. So guys, number 2 is just like a more advanced version of number 1. So we're distributing, but maybe it's a little more obvious of what we're distributing here. So we're distributing that -10 and we're distributing the +6. So I'm multiplying that in. So I get a +90, so be careful with signs. I get a +6x and a -60 here. And now we're going to look to combine our like terms. So we're going to put together, yeah, Carson? What? The x's. So 90x and 6x is going to be 96x. So we just add those. And then -10, -60, down 10, down 60 more. So -70, right? And the order you put this in doesn't matter. We just call this like standard form where I put the x term first. And again, this is, hopefully this will jog your memory. You guys will remember these different types of problems. So our next one here. What's that? Yeah, so guys, so this next one, number 3, we used FOIL for this. So if you guys recall, FOIL was just an acronym to help us remember what to do in what order. It really doesn't matter if you go in the right order of the letters of FOIL, but it helps you remember what we need to do here. And actually this one is also FOIL over there if you're curious. So first, we're multiplying those first 2 terms together. And so I'm multiplying as I go here. So that's going to be 48, and that's going to be p to the second, p times p. And we'll talk about some of those exponent rules in a little bit more here. Then I'm going to do outer. So 8p times 2 is 16p. Then I'm going to do inner. So that's a -12p. And then I'm going to do last. So -2, +2 is going to be a -4. And again, I multiplied on that step. Are you okay with that? And then I have some like terms in the middle there. And those like terms can go together. And again, when I add them together, I just add their coefficients. So the numbers in the front, I don't change the exponent. So 16 minus 12 is going to be 4. So this is all foiled through, simplified as much as we can. Good with that? Now number 4, we did talk about a problem like this not that long ago when we were talking about our circle chapter. What do we need to remember to do with the 3x minus 7 squared? Yeah, it's telling us to square that. It's telling to multiply by itself. So we're going to write 3x minus 7 and then multiply it times 3x minus 7. And we're just going to do FOIL again. We cannot distribute that power in, so don't take that 2 and multiply that in there. So first, 3x times 3x is 9x to the second. Outer is going to be a -21x. Inner is also going to be a -21x. And then last is going to be positive 49 because a negative times a negative is a positive. Now we're going to combine those middle two, those like terms. Now since they're both negative, they become more negative. So they just become like not minus 21 more, so minus 42 or a negative 42. And so all the stuff we're talking about here, again, this is not going to be on our exam. We are going to do like that skills test, but if you guys walked into Algebra 2 knowing everything from what we're learning today and also next Tuesday, Mr. Hatfield would be really excited. Obviously, you're not going to remember everything still, but a little bit review is helpful. And if you're not taking Algebra 2, like I said, you're going to end up using it at some point, somewhere. Again, you're not done taking tests altogether for math, so even if you're not taking Algebra 2. Okay. So our next one here. Now this one is not FOIL. I don't know what it is, but when I teach my algebra students FOIL, they want to FOIL then on everything. They see anything with 2 parentheses and they're like, let's FOIL. What's number 5? What are we doing instead?
Distributing.
Yeah, we're distributing that -1 again. So this is really just like a subtraction problem. But I'm going to like distribute the -1 in and just combine the like terms. So this one's not going to change. This is going to become a -3a squared and then a positive 4a to the third. So I'm distributing that negative in. Now we can combine our like terms. So this is a 1a to the third and a 4a to the third. So 1 and 4 is just going to be 5, and then I leave that exponent the same because I'm adding here. Then these two go together, and it's a -5a to the second. Are we okay? And then our last one on this side is really just asking us to distribute, and this now is bringing in some of those exponent rules that when I'm multiplying those in, there's a little bit different exponent rules than when we're adding. So I'm going to distribute this 5a to the second in to all 3 of these. And when I'm doing that, we're multiplying it in. So I'm doing 5a to the second times 4a to the second. 5 times 4 is 20. And then how many x's am I going to have? 4 of them. Now minus 5 times 3 is 15, and then x to what power?
2, 3.
There's going to be 3 of them. There's 2, and then I have another one. They're coming together, so that's 3. It's a little bit confusing there. It's really almost like we're adding the exponents, or we are adding the exponents. And then plus 5 times 2 is 10, and then x to the second. All right? Yes? But good question. So he was asking about adding here. 2 negatives though, think about it as like losing money. You lost $2, you lost 3, you've lost 5. So the rule you're thinking of is multiplication. This is adding here. So yeah, we don't actually multiply in that case, or like change it to a positive. Okay?